With law of sines, sometimes there's what is called an ambiguous case. And this happens when you have an angle given that is acute and the side opposite that angle is smaller than the other side given. I will post a applet where you can see why this happens as well. But what happens is there are two possible triangles, and so you have to see or solve for both of those possibilities. Now let's start the same way we did before, and let's set up our triangle. And remember that with law of sines, we have to have that opposite pairing. So here's ABC, and so we know that this is 40 degrees. And that this A equals 5. So there's your opposite pair, angle and opposite side. And then we also know that little b is 7. If you notice, the side opposite an acute angle is smaller than the other side given. So we need to solve for two triangles. We start off the same way we did before, and we set up our ratio. So we're going to use A, sine of A over little a equals, and notice we're given something with B, so let's use B with it, sine of B over little b. Let's plug in what we know. We know that angle A is 40 degrees, and side A is 5. We do not know angle B, but we do know that side B is 7. So we're going to solve just like before. We're going to cross multiply and divide. And when you do that, you'll get that sine of B equals 7 sine of 40 degrees all over 5. We multiplied these two together. That's my numerator. And we divided by 5 to get B by itself. Okay, so let's go to our calculator and plug that in. So we're going to do inverse because we're looking for the angle. So second sine of 7 sine of 40, okay, divided by 5. And we get that angle B is 64.1, I guess, 1.5. Let's use that. So angle B equals 64.15 degrees. However, we have two options for B. So to find the other B, let's call this one B1. To find B2, okay, so this is the other option for angle B. It is supplementary to what we found with our calculator. Supplementary means it adds to B180. So to find the second version of angle B, we're just going to take 180 degrees and subtract what we just found, 64.15 degrees. So let's figure that out. So 180 minus 64.15, and we get 115.85. So option 2 is 115.85 degrees. All right, now we need to solve both of these triangles. We need to solve one triangle with B1 and another triangle with B2. So I kind of like to separate my paper at this point. So this is going to be triangle 1, and that's going to have B equaling 64.15 degrees. So let's solve this triangle first. Okay, if B1 is 64.15 degrees, C1, angle C, all we're going to do is take 180 minus 40 minus this to figure out what angle C is. So let's clear this out. 180 minus 40 for angle A minus 64.15 for angle B. And we find that angle C for the first triangle is 75.85 degrees. 75.85 degrees. Now, we have side A, side B, and we have all three angles. We just need to find side C. So let's put in, use the law of sines again, and this time we're going to go back to angle A. I like to start with what's given. So sine of 40 degrees over 5 equals sine of, we're going to use angle C, 75.85 degrees over side C. All right, let's cross multiply and divide. And so we're going to multiply these two together. So C sine of 40 equals 5 times the sine of 75.85 degrees. Divide both sides by sine of 40 degrees to isolate C. And we're ready to go to our calculator. All right. So we're going to do 5 sine of 75.85, make sure you close that parenthesis, divided by sine of 40. And we find that side C1 equals 7.54. So triangle 1 has been solved. Now let's look at triangle 2. Okay, so triangle 2 has angle B, we're going to call it B2, equaling 115.85 degrees, which means that C2 equals 180 minus 115.85 minus, and then A, which is 40. And we get that the second version of angle C is 24.15 degrees. 24.15 degrees. Now let's find little c. Okay, we're going to do exactly what we did here, except we're going to swap out this angle C with this angle C. All right, so sine of 40 degrees over 5 equals sine of angle C, which is 24.15 degrees, over little c. Let's cross multiply and divide, and we see or find that little c equals 5 times the sine of 24.15 degrees, all of that over the sine of 40. Let's plug that into our calculator. So, 5 sine 24.15 divided by sine of 40. And we get 3.18. So little c, or C2, is 3.18. Now we have solved both triangles in this ambiguous case.